Welcome to MV Tutors. I'm your tutor today, and we are doing the topic of momentum and impulse. So, what we're going to do is that we're going to go through some theory and then we'll go over this question here. Now, I like to start with a vision in mind before we do our theory. So, if you look at this question here, it's a past exam question. It was a question number 4. Okay, so what we can see here is the vision. This is what we want to ultimately answer, be able to answer rather. But first, we need to go through the theory before we answer this. But let's just read through it real quickly. So it says the diagram below shows two trolleys, P and Q, held together by means of a compressed spring on a flat, frictionless, horizontal track. The masses of P and Q are 400 grams and 600 grams respectively. Okay, we can see them in this picture over here. When the trolleys are released, it takes 0.3 seconds for the spring to unwind to its natural length. So as we can see from this picture here, the spring is already compressed. Okay, and we are also told that the spring was compressed over on top here, compressed spring. Okay, trolley Q then moves to the right at 4 meters per second. Okay, there's Q. It moves after you release them. You release the spring from compression. It stretches out. So Q, we're told it moves to the right. Okay, then they say states the principle of conservation of linear momentum in words. Okay, that's the vision. We need to be able to answer that. And then calculate the velocity of trolley P after the trolleys are released. And then the magnitude of the average forces exerted by the spring on trolley Q. Then they ask, is this an elastic collision? Only answer yes or no. Okay, now if you don't know to answer any of these questions, then stick around and let's get through the theory. All right, let's get started. Well, number one, what is momentum? Okay, so there are a few things that we need to understand about momentum and what it is. Okay, so what is momentum? So momentum is given by the equation P is equals to m times v, where P is the momentum. It stands for the momentum. Okay, so momentum is denoted by P and not M. I don't know why they chose P. I think it's weird, but there are many symbols in science. So I'm sure they couldn't use M because M is already taken by many definitions. For example, M in this case means mass. Okay, and then V is velocity. Now, what's the difference between velocity and speed? Well, velocity is actually a vector, and it's a vector, meaning it has direction. It includes direction. Okay, whereas speed is scalar, meaning you just give the magnitude, whereas velocity is a vector, so it gives magnitude and direction. Okay, now the mass is in kgs, and then the velocity is in meter per second. Okay, So then when we are talking about momentum, let's just look at the units. It's mass times velocity, where mass is in kg and velocity is in meter per second. So since momentum is just the product of mass times velocity, you multiply the units as well, and then these are the units of momentum. It's in kg per meter per second. It's kg meter per second. All right. Now we are done with the momentum. We need to understand what impulse is now. Let's talk about impulse. Okay, so impulse really is just to take you to the end. Impulse is really, it's just the change in momentum. Let me put it that way. It's the change in momentum. Okay, so keep this in mind. I'll show you how this comes in, but first let me just give you the definition of impulse. Impulse is actually equals to, it's the product of the net force, okay, times the change in time. Okay, now the reason why I say it's a change in momentum is because of the units. When you work this out, you find out that force is actually, it's just mass times acceleration, right? And then change in time, let's leave it as change in time. And then if we look at it further, mass times acceleration, mass is given in kg. If we look at the units, acceleration is meter per squared seconds. Okay, those are the units of acceleration. And then time is in seconds. So, which means if we are to multiply these all together, we have s minus 2 and we have s1 there. Now, if you know your mathematics of exponents, you know that you just add the exponents to give you 1. So eventually we'll have kg m, and then we'll have s minus 1. Okay, now if you look at this, these units are exactly the same as the units of momentum. So therefore, impulse is just the change in momentum. So we can say the change in momentum, which is change in p, is equals to F net times a change in t. Okay, because they both give you the same unit, so they are equal. Okay, so keep this equation in the back of your mind. We will need it in some of these questions. I just wanted to demonstrate where this equation comes from. This is the equation of impulse. It's just a change of momentum is equals to the product of the net force times the change in time. Okay, now there's one more thing I want us to talk about. It is the law of conservation of momentum. Okay, there we go. Now, what this law basically says is that in an isolated system, okay, so the system has to be isolated. In an isolated system, the total linear momentum is conserved. That's why it's called the law of conservation of momentum. So the momentum is actually conserved. What does this mean? It means that the sum of the momentum before is the sum of the momentum before is equal to the sum of the momentum after. To the sum of the momentum after. Okay, so this is actually denoted by saying the sum of the momentum before collision is equals to the sum of the momentum after collision. Let me just put the word collision here. Okay, so because of this, we can also test for something called elasticity. Now, what is elasticity? An elastic collision is a collision where the kinetic energy is also conserved. Okay. Now, the kinetic energy is given by this equation. This is the energy that is kinetic. It's given by the equation half mv squared. Okay. And for elasticity, I'm saying to you elasticity, it's the sum of the kinetic energy before is equals to the sum of the kinetic energy after collision. Okay, so always relate the elasticity. This is for elasticity. If the sum of the kinetic energy before is not equal to kinetic energy, it's inelastic. It's not elastic. So what I'm saying is that if the sum of the energy, which is kinetic before, is not equals to the sum of the energy of the kinetic energy after collision, then this is inelastic or not elastic. This is not elastic. Okay, so I think that's all the theory that we need to learn before we can tackle those questions. And when it comes to the topic of momentum, indeed, this is the only theory that you have to learn at this stage. So let's get right into the question. Okay, 4.1. State the principle of conservation of linear momentum in words. We spoke about this earlier. I'm just going to put it in different words. But in a closed system, the total momentum before collision is the same as the total momentum after collision. Okay, that's all. All right, then let's jump into 4.2.1. It says calculate the velocity of trolley P after the trolleys are released. As you can see, the trolleys there. So they've asked us about the theory of the conservation of momentum. So now we just need to apply it. Remember, we're just gonna say the sum of the initial momentum is equals to the sum of the final momentum. It's the same as saying the momentum initial is the same as saying the momentum before, and then final is the momentum after collision. So that's it. Okay, so now what we're gonna do is that we're gonna put them individually. Now remember, the formula for momentum is the product of mass, okay, times velocity. So the mass, we have the mass of P, okay, if you remember, and this is the initial one, and then we have the velocity of P, the initial one, okay, plus, if it's sum, then it's plus the mass of Q, the initial one, times the velocity of Q, the final one. Okay, this should be equals to the mass of P, the final one. Mass is always the same anyway, but we'll just put final. Actually, we don't even need to put the P's and the initials and the finals on the mass because it's the same, but for consistency's sake, let's just put it. And then velocity of P, the final one, plus the mass of Q, the final one, times the velocity of Q, the final one. All right, we can now go on and then put in the variables. So the mass of P, before I solve this, let me just solve the masses, the individual masses. So the mass of P is equals to, let's go see in the question, P is 400 grams. Okay, so it's 400 grams. But if you remember that the units for momentum when it comes to the mass is in kg, so we need to convert the grams into kilograms. Okay, so we'll divide by 1,000 and then we'll get 0.4 kilograms. That's it. And then the mass of Q, what was the mass of Q? It's 600 grams. So likewise, we'll take 600 and divide it by 1,000. We'll get 0.6 kilograms. And then another thing, when it comes to velocity, remember now velocity is a vector. So when it comes with a direction, so we needed to choose a positive direction. If the examiner does not tell you which way is the positive direction, you basically have to choose it yourself. So we're going to choose right as positive direction. Okay, so if the system is going to the right, it's positive. If it's going to the left, it will be negative. Okay, we're ready to answer the questions now. Okay, we're bringing down this formula. MP is 0.4. okay, and v is velocity. The initial velocity is 0 for both of them because they are stationary, they're not moving. Okay, mq is 0.6 times initial velocity of 0. Okay, coming this side, we have mp, which is 0.4 times, let's go check the velocity. We are not given the velocity of p afterwards, but we are told that trolley q moves to the right at 4. Okay, so which means when it comes to here, we'll put the v, it's v p f, plus, because it's moving to the right, so it's a positive direction for the velocity. So then we'll put, what was it? I forgot the number. It was 4. It was 4. Okay, so this is all 0. Then we have 0.4 VPF plus 0.6 times 4. Okay, let me just leave it like that for now, because I don't have a calculator with me immediately. And then basically I want to make VP the subject of the formula. So it's going to be minus, it's going to be, if I take this to the other side, minus 0.6 times 4 divided by 0.4. That's just some little bit of maths, okay, on how to make things the subject of the formula. Now if I put this in a calculator, I will get minus 6. Okay, that's my VPF. Now what does this mean? Remember that we are talking about a vector, so you cannot get a velocity that is minus. If it's minus, it just means a change in direction. So what this means is that VPF is equals to 6, okay, the units, meters per second, to the left. And that makes sense because if you look at this spring, it's compressed. So if you release it, this Q must go to the right while P must go to the left. So the calculation actually confirms that. And then 4.2.2 says the magnitude of the average force exerted by the spring or trolley Q. So we are talking about the force on trolley Q alone. Okay, so if you remember that formula for impulse that we did, it's 4.2.2. It's 4.2.2. 4.2.2. Now, if you remember that formula for actually impulse, we said its change in momentum is equals to the net force times the change in time. Okay, because we are talking about Q, the change in momentum, the mass stays the same. What changes is V, the velocity. So it's the final velocity minus the initial velocity. It should be equals to F net times the change in time. Okay, so we know that the mass of Q, put Q there, of Q is actually 0.6. We know that its final velocity as given was 4. minus the initial velocity was 0 because it was stationary. And the force net, that's what we're looking for. But then the change of time, we were told that it's 0.3. Okay, so it takes 0.3 seconds for the spring to unwind to its natural length. So that's the change in time from 0 to 3 seconds. It's the same as doing final minus initial. It's just that now the final minus initial has given us 0.3. Okay, so eventually what we have here, if we isolate, if we make F as the subject of the formula, we'll have F net. This side will have 0.6 times 4 divided by 0.3. Okay, that's 0.3. We put this in a calculator, we get that the F net is 8. Okay. So therefore, we can conclude that the force, the net force, is 8 newtons. Force is always in newtons. Okay, that's our final answer. Okay, let's go to the next question. The last one. Is this an elastic collision? Only answer yes or no. Okay, that's fine. Let's get into it. So 4.3. Now, if you remember something about elastic collision, we say something is elastic if the kinetic energy initial is equals to the sum of the kinetic energy final. Okay. Now, and we know that kinetic energy is given by half mv squared. Okay, so the initial one is going to be, because the initial velocity is 0 and the final velocity is a number, we can say it's not elastic. They said we must just say yes or no. Okay, so therefore no. But even though they said we must just say yes or no, I want us to calculate it, okay, just to confirm it, because the purposes of this tutorial is also to go beyond the scope. So let's actually calculate it. So we have, when we write the formula, it will be half mass of P and the velocity, the initial velocity, its initial velocity. And then that's going to be plus half the mass of Q and its initial velocity. Okay, this is before. This, we need to see if it's going to be equal to, it's elastic if it's equal to the mass of P and the final velocity squared plus half mq plus, times its final velocity of q. All right, so because we know that the v's are initially a 0, we can just put 0 here because we already know the velocity, both initial velocities are 0, so we'll have 0. And then this side we will have half m mass, which was 0.4 of p, and then a v, the final velocity of, didn't we calculate it? I think we calculated it somewhere. The final velocity of 6. We calculated it to be 6. Okay, squared. So we already know that it's not going to be equal, so I'm just going to put not equal to, because this will give us an actual number. This side, it's going to be half. MQ was 0.6, and its final velocity was, I think it was 4. Let me just verify. Yeah, it was 4. It was 4. It was 4. Okay, so that, if we calculate all of this, that 0 we already know is not equal to, if we calculate all of this, this one is gonna give us, it's gonna give us 12 joules. Okay, it's always, the units are always in joules. So 0 is not equals to 12, therefore it's not elastic. Okay, that's it. Well, I hope you understood. If there's something you didn't understand, do comment and ask for a tutorial, or visit our website and ask for our tutorial. Otherwise, just like and subscribe to this page. We would love to hear from you. Comment as well. Thank you so much.